You buy a new 2026 vehicle in the spring. 18 months later, on a highway on-ramp on a Tuesday morning, the car begins slowing down on its own. No warning, no impairment. Sun glare hit the infrared camera in your steering column at a low angle, the driver monitoring system read it as eye closure, and the throttle reduction kicked in before you could react. You get to the shoulder safely. You call the dealer. They run the diagnostic, confirm a camera array fault, and quote $2,600 to $3,800 to replace the sensor suite and recalibrate the steering grip sensors. The repair is not optional. The system logged a fault code and will not clear without the replacement. Your car is 18 months old. This is not a fringe scenario. This is the predictable consequence of mandating a complex, unproven sensor system into every new vehicle sold in the United States on a legislative timeline that had nothing to do with whether the technology was ready. Today, I'm going to show you exactly what the mandate requires, how two major manufacturers are already generating false interventions in pre-mandate implementations, and why the car you buy in the next 12 months may be the most financially important vehicle decision of the next decade. There is a template for how automotive safety technology is supposed to work, and it has produced some of the most reliable systems ever installed in a consumer vehicle. ABS brakes were introduced in limited applications in the late 1970s, refined through voluntary adoption across the 1980s, and not mandated until the technology had accumulated a decade of real-world reliability data across diverse climates and driving conditions. Airbags entered the market as optional equipment in the 1970s, went through documented failure analysis including fatality events that led to design revisions, and were mandated in 1998, roughly 20 years after their introduction, when the deployment reliability and injury profile were understood well, enough to require them universally. The pattern is consistent: voluntary adoption, real-world failure identification, engineering refinement, then mandate. The passive impairment detection requirement entering 2026 model year vehicles compresses or eliminates that sequence entirely. The technology is moving from limited pilot deployment in premium vehicles to universal installation across every new car sold in America on a calendar set by Congress, not by demonstrated engineering readiness. The repair infrastructure has not been built. The technician training does not exist at scale. The parts supply chain is not stocked for the volume the mandate creates. Here is what is inside the system and what it costs when it fails. The primary sensor is an infrared camera array, typically mounted in the steering column hub or the instrument cluster surround, positioned to monitor eye closure, gaze direction, and head orientation as proxies for driver impairment. The location is dictated by line-of-sight requirements to the driver's face. It is also directly in the path of low-angle sunlight entering through the windshield, dashboard surface reflections, and the condensation and dust accumulation of normal vehicle use in real climates. Early OEM implementations in 2024 and 2025 model year vehicles, before the mandate made the system universal, are already generating replacement costs of $1,800 to $3,500 at dealer service centers. Independent shops cannot currently perform the recalibration. The procedure is locked to manufacturer diagnostic tools under proprietary software restrictions, which means approximately 70% of the post-warranty service market. The independent repair shops, where most Americans take their cars after the dealer warranty expires, cannot touch this system. When it fails out of warranty, you go to the dealer, you pay dealer rates, and you wait. Current backlogs on camera array replacements at GM dealers are running 4 to 8 weeks in. Affected markets. The second failure point is built into the wheel in your hands. Capacitive grip and touch sensors are embedded in the steering wheel rim as a secondary impairment indicator, measuring hand presence and pressure patterns. These sensors are not independently serviceable. They are integrated into the steering wheel assembly at the manufacturing level, which means a failed sensor is a full steering wheel replacement. $800 to $1,400 for the assembly, plus the recalibration visit that follows. On a 3-year-old vehicle, that is a repair bill for a component that existed to monitor whether you were holding the wheel you were already driving with. The third problem is not a component. It is an architecture. Every previous driver assistance system, lane keep assist, automatic emergency braking, forward collision warning, could be disabled by the driver or managed around when it malfunctioned. The passive impairment detection system under the mandate is required by the regulation to be non-bypassable in its monitoring function. A system that cannot be switched off and whose malfunction cannot be temporarily overridden by the driver is a new category of failure in automotive history. A false positive impairment reading does not illuminate a warning light you can choose to ignore on the way to the dealer. It reduces your throttle on a highway on-ramp, and there is nothing you can do about it in the moment. Now let's talk about who is implementing this badly, specifically. General Motors has been deploying driver monitoring technology across Cadillac, GMC, and Chevrolet platforms through their Super Cruise and Ultra Cruise systems in advance of the 2026 mandate. Documented false impairment detections in 2024 and 2025 model year vehicles, particularly in high-contrast lighting conditions, have been reported by owners and acknowledged in technical service bulletins. GM's proprietary calibration software locks every recalibration procedure to dealer tools, locking out the independent repair market entirely. Parts and recalibration backlogs at GM dealers in affected markets are running 4 to 8 weeks, with loaner vehicle availability inconsistent. When your car's mandatory safety system fails, GM's service infrastructure is currently not scaled to fix it on any timeline that resembles normal automotive service. Subaru's EyeSight system, being expanded to meet mandate requirements across their 2026 lineup, has a documented sensitivity profile that generates elevated false positive rates in low sun angle conditions. This is not an inference from owner complaints. It is acknowledged in Subaru's own technical service bulletins, which recommend dealer recalibration as the response. That recalibration runs $400 to $600 per visit. Subaru owners in northern latitude markets have reported EyeSight interventions during winter, morning commutes at frequencies that suggest a system calibrated for test track conditions and not for the actual lighting environment of a Minnesota February. Both GM and Subaru are implementing systems that perform adequately in controlled evaluation conditions and degrade in the real-world diversity of climate, angle, and driver behavior that characterizes 250 million daily commutes. Before I tell you what to buy, drop a comment right now if you have experienced a false intervention from any current driver assistance system. Lane keep assist, pulling you toward the lane line. Automatic braking activating on a clear road. A driver attention warning. Triggering while you were alert. Tell me what it cost you if it required a service visit. I want to know what the false positive rate looks like. Outside the manufacturer's test data, because the number they publish and the number technicians are seeing are not the same number. Here is what the math supports, buying right now. A 2024 or 2025 Toyota Camry, RAV4, or Tacoma is the primary recommendation. Toyotas. Pre-mandate driver monitoring implementations are limited to attention warning systems that alert without intervening, and Toyota's electronics reliability record across J.D. Power. Initial quality and consumer reports, long-term reliability surveys is among the strongest in the mass market. A certified pre-owned 2025 Toyota with documented service history is a more financially rational vehicle than a new 2026 model carrying an unproven intervention system on its first mass market deployment. The 2025 does not have the mandate. That is the specification that matters. If you are committed to buying new, the 2026 Mazda 3 or CX-5 represents the most conservative implementation of the mandated system currently available in the volume segment. Mazda's iActiveSense suite has generated lower false intervention complaint rates than GM, Subaru, or Ford equivalents in early adoption data, and Mazda's historical pattern of implementing driver assistance technology with more conservative intervention thresholds is the closest thing to a reliability indicator the 2026 market currently offers. Avoid any 2026 GM platform vehicle carrying Ultra Cruise. Avoid any 2026 Subaru with the expanded EyeSight suite. Avoid any 2026 Ford carrying Blue Cruise 1.3. All three are being scaled to mandate compliance on a timeline that Consumer Reports and J.D. Power analysts have flagged as ahead of demonstrated reliability benchmarks. Here is the rule. 2 sentences. Check the model year. Check whether the system warns or intervenes. A system that warns is an annoyance when it fails. A system that intervenes is a $3,000 repair and a highway hazard when it fails. Every 2026 vehicle has intervention capability by federal requirement. Every 2025 vehicle does not. The mandate solves a real problem. Impaired driving kills 37 people per day in the United States, and that number has not meaningfully declined in a decade. The technology being mandated to address it may eventually be reliable, enough to justify universal installation. It is not there yet. The implementation timeline was set by legislative calendar. The engineering readiness timeline was not consulted, and the repair infrastructure needed to service 16 million new vehicles per year. Carrying this system does not exist in the form the mandate assumes it does,